Hi, this is Florian. In this video I would like to show you how to set up the quantification of the transcription sites and then also how to save those settings to use them in the batch processing mode to process all of the defined sites in all of your cells. So we start again from the main interface of FISH-QUANT. We now change the folders for the results and we change it to the folder for the nascent mRNA quantification. Here you see that I already copied two files that you can also find in the example dataset. The first one is an image file. It's the averaged image of the mature mRNA that was obtained by averaging together around 5,000 individual files. And the second file is this list of all of the detected spots that contains the information that we need for the quantification of the transcription site. After we defined that, we go to Tools, Transcription Site Quantification, which brings up another user interface, and here we can set up all the different parameters of the transcription site quantification. The outline is already loaded, the same outline as shown is in the main interface. We now have to define a few parameters. First, the image of the mRNA. We click here, brings us automatically to the folder with the results. We select this TIFF file. Parameters, usually you just have to confirm them. It takes the same parameters that we've seen in the main interface. Define background. This is the background of the averaged image of the mRNA. This is only necessary if you want to use the quantification approach based on the PSF superimposition. If not, you can simply set this to 0. I will now show you how you can actually define this background and how you can measure it. For this, I usually use ImageJ or any other kind of imaging processing program. So you open ImageJ. You can then load your image by simply dragging it into ImageJ. You see here it's a C-stack. We can then just measure the background in an area away from the center. For this I select a rectangular selection. Then in the menu you go to Image, Stacks, Plot Z-axis Profile. We see it's relatively constant around 243. So this is the value we're going to use for the background, so 243. We close this. For the background we take now, we can use a scalar or a file. A file should be an image file of the same dimensions than the actual image of the mRNA that defines the background. We just use a simple scalar, set it to 243. Then we have to define the amplitudes of the individual mRNA molecules. We can get that either from the analysis from the main interface, or we load a file. In this case we load the file that I already copied to the results nascent folder. FISH-QUANT will load this file. You see here this is a histogram where you have the amplitudes and the normalized intensity. In red you see a fit with a skewed normal distribution. Then FISH-QUANT will ask you if you want to use this distribution for the quantification or you want to use its mean value. In this case we have a nice distribution, so we're going to use the distribution. Then we press on Analyze Settings. This will process those settings. You see first here, this is the averaged image of the PSF on the left side, and this is a fit with a 3D Gaussian. Those are the residuals. You see the fit very well describes this function. We now have a few seconds until the processing is done. Then we can apply those settings to quantify either a currently selected site or all of the sites in the images. We can also use the parallel computing as before, which I enable here. Here you can then choose which of the cells and which of the transcription sites you want to process. You can here enable that you use the PSF superimposition approach. You can press here simply on selected site, which will then process this particular selected site. We'll show you in the main interface some more details of the reconstructions, how many nascent transcripts we have with the different methods that were implemented. One practical option is down here, where you can restrict the size of the transcription site by estimated by the PSF superimposition approach. FISH-QUANT basically simply removes placed PSFs that are further away than 1000 nanometers from the center of mass of this transcription site. This helps to get rid of placed PSFs that are used to describe inhomogeneous background, or if you have individual mRNA molecules that you can find outside of the transcription site. And now quickly want to show you some more advanced options that you can find in the menu under options. All of those are explained in full detail in the user manual. Interesting ones here for background auto detection. The background for the PSF superimposition approach is automatically detected by sample a number of default values. FISH-QUANT basically determines the background in the nucleus, or if that's not defined, in the cell around the transcription site, and then determines a number of values it wants to sample. In this case, it will take 10 values that are determined based on the mean value and the standard deviation of this background. So between 3 times the standard deviation minus the mean value and 1 times the standard deviation plus the mean value, FISH-QUANT will use 10 values. We can use more here. We can set this to 20 and 3. So we scan a larger area to determine the best optimal background. After we set this, we can simply save those settings. Again, from the menu, save settings. We can save those to the results folder. And now we are done. We can now proceed with the same quantification in the batch interface, which I will show you in the next video. All of the options and more details about how the transcription site quantification is actually implemented you can find in the help file. So I invite you to look at the help file in more detail if you have any more questions.